Hello there. Today we are going to be explaining solving and graphing linear inequalities. Inequalities are mathematical statements that compare between two quantities. Let's start by solving. Say, I have an inequality like this. 2x plus 1 is more than 3. To see all possible values that satisfy x, we have to isolate it on this side first. Start by subtracting 1 from both sides. So now it becomes like this. 2x is more than 2. Now we can divide both sides by 2, so x is more than 1. That means that if we plug in any value bigger than 1 in our original inequality, it is going to be bigger than 1. So the solution set for x is all numbers bigger than 1. Let's try another one. 3x minus 7 is more than or equal to 2. We can isolate x by adding 7 on both sides. So 3x is more than or equal to 9. Then we can divide both sides by 3, so x is more than or equal to 3. That means any value more or equal to 3 satisfies the inequality. Therefore, the solution set looks like this. Now let's move on to graphing inequalities. Let's take this inequality, for example. Y is more than or equal to 2 over 5x plus 3. To work with this kind of inequality, we convert it into the slope-intercept form. Y equals mx plus b. So now it looks like this. To get started, we have to plot the y-intercept, which is 3. Then we plot the slope, m, as a point. Since it's rise over run, the point rises 2 units and runs 5 units. Now that we have 2 points plotted on our graph, we can connect them using a line. To find out the shaded region, we use a test point. Take, for example, 0 and 0 because it's an easy point to work with. We can substitute the y and x in the inequality with the y and x in our test point, which are 2 zeros. Then we simplify the inequality. If the simplified inequality is true, we shade the region that has the test point. And if it's not, we shade the other region on top of the line. Since this inequality is false, we shade the upper region, and we're done. All the values in the shaded region satisfy the inequality. There is also a difference between the types of lines used for the boundary line. The solid line is used when the inequality contains less than or equal or more than or equal, which means some points on the line can't be a solution to the inequality. And dashed lines are used when there is more than or less than, which means that the values on the line don't satisfy the inequality. I hope this video helped you understand graphing and solving inequalities. Make sure to like and subscribe for more.